Today we're going to talk about sequences and series. So we're first going to talk about sequences, and tomorrow we'll talk about series. So an arithmetic sequence is a sequence in which the difference between any term and the previous term is a constant. If the difference d is positive, the sequence is increasing, and if the difference is negative, the sequence is decreasing. A function in which the domain is usually the set of positive integers and the range is the set of terms in the sequence. So let's look at an example. First, we have to know what some of the symbols are. So the terms, or the numbers in the sequence, the first term I would refer to as A1, the second term you refer to as A2, the third term is A3, and so on. The common difference, or how you get from one term to the other, is called D. And the number of terms we will call N. So if I have an example that says find the 40th term of the sequence 2, 5, 8, first we have to figure out how many differences would you have to add to the first term in order to get to the 40th term. Well, if you have 40 terms, you actually have 39 differences. So I have 39 differences. I have to start at the first term, and 39 times I have to add whatever that common difference is. Well, if I look at the sequence 2, 5, 8, you can clearly see that the common difference is 3. I would add 3 every time. So I'd start at 2, and I'd add 39 differences, or 39 times 3, or my 40th term would be 119. So there's actually a formula that you can use, and that would be AN, or any term, equals the first term plus the number of terms minus 1 times the common difference. So if we have an example here, I know the 20th term is negative 111. I know the common difference is negative 6, and I want to find the first term. Well, here's my formula. Let's plug in what I know. The 20th term is negative 111. I want to find the first term. I know there are 20 terms because it told me that the 20th term is negative 111, so I know the number of terms has to be 20. 20 minus 1 is 19, so that's how I get the 19 here in the formula. And the common difference is negative 6. My only variable is A1, so I can just solve this equation for A1, and I know that the first term in this particular sequence would be 3. Let's look at another example. Well, here they tell me that A6 is 25 and A10 is 39, but I don't know what A1 is, and I don't know what the common difference is. And those are the two things that they want us to find. So let's think about what this is saying. They're saying you have some numbers, 5 numbers before 25, because 25 is the 6th term. And then you have a couple more numbers, and then the 10th term is 39. Well, we can think about this piece of our sequence as being the first part of our sequence. We could call 25A1, and then if I called 25A1, then 39 would be A5. Well, I can use that information in order to figure out what my common difference is. So here's my formula. I know that A1 is 25 and my last term is 39. I have to add n minus 1. Well, here in the yellow block I have 5 terms, so 5 minus 1 would be 4. And d, the common difference, is my only variable. I can go ahead and simplify this equation and then solve for d. And I know my common difference is 3.5. Now that I know that the common difference is 3.5, I can use this equation again, but now use the full sequence in order to figure out what the first term is. So I know the last term is 39. I want to find the first term. The last term was A10, so I know there's 10 terms. So n minus 1 would be 10 minus 1, which is 9, and we already found the common difference to be 3.5. Go ahead and solve this equation for A1, and you know your first term is 7.5. You can check to see if this makes sense by simply saying 7.5 plus 3.5 is 11, plus 3.5 is 14.5, plus 3.5 is 18, plus 3.5 is 21.5, plus 3.5 is 25. So that makes sense. Sometimes you will be asked to write a formula or a rule that describes a sequence. So here's my sequence. Every arithmetic sequence has its own unique A, 1, and D. So if I find those, I have my rule. So basically, if you take a look at your formula, I would leave everything as a variable except A, 1, and D. So if we look at this sequence 2, 5, 8, I know my first term is 2. The number of terms, n, is going to stay n as a variable, and my common difference is 3. 2 plus 3 is 5, 5 plus 3 is 8, and so forth. All I have to do now is distribute this 3 and combine all my like terms, and I have my rule, 3n minus 1. If you were to graph this, you would figure out that this would be a linear function. If you have any questions, please let me know.